Bismillahirrahmanirrahim. I am Professor Jamil and you are watching YouTube channel. Today we are going to have a problem, an important result on a Laplace transform, and let's do this in the form of the statement of a question which may appear in your exams as well. Prove that Laplace transform of this Tn to the into Ft is equal to this one, where s, this is the derivative with respect to s, and s is what? S is the variable. The transform means Laplace transform depends on, the transform depends on the variable s, and with respect to that variable you have differentiated the Laplace transform of ft, and you need to prove that this result is equal to this, right? So for proving this result, from where you should start? Look, you are taking derivative with respect to s, and the derivative is to be taken of the Laplace transform of ft. So you should start from the Laplace transform of ft and then differentiate it with respect to s. Let's do this. Solution. We know that Laplace transform of ft is equal to, t is the old variable now, and it will be integrated from 0 to infinity with respect to t, and then there will be a kernel for the Laplace transform, which is e to the power minus s into t, where s is the new variable and t is the old variable which is present in your function. Multiply by this ft whose transform is required. Now this is the Laplace transform, and according to the result you need to differentiate it with respect to s. Let's differentiate. Differentiate with respect to s, right? So this is d by ds of Laplace transform of ft, and it is equal to d by ds of whatever on the right hand side is 0 to infinity dt into e to the power minus st into ft. Now look, here your variable of integration is t and variable of differentiation is s. These are two different variables, and for this case you can switch the order of integral operator and derivative operator. Should there be the case that variable of differentiation, mean s, and variable of integration were same, mean d by dt, then this operation of switching the operators cannot be done, right? So let's write the statement as variable of differentiation and variable of integration are different, so we can switch the order of operators on right hand side. Let's do this. Mean d by ds of this is equal to this. Interchange. Integral sign first and d by ds later on, and everything else is here. dt e to the power minus st into ft, right? Now you have to differentiate with respect to s, and there is no differentiation with respect to t. So you can make this d by ds as partial over partial s, because you need to differentiate only with respect to s and not with respect to t. There are two variables here. One variable is t and the other variable is s, but you are differentiating with respect to s only. So the d by ds, when will move inside, it will turn into a partial derivative, so that it tells you that differentiation with respect to s is to be taken only. Right? Now, when you need to differentiate with respect to s, then t will be treated as constant. So this will not be differentiated. This will not be differentiated. Only the exponential will be differentiated. dt and ft will be treated as constants. So in the next step, you have d by ds of the Laplace transform of ft equal to t0 to infinity. Dt is as such, and partial over partial s is of e to the power minus st only, and the ft is also out of the partial over partial s operator. So differentiate this only. Here you have t0 to infinity dt, and derivative of the exponential is exponential, and then derivative of the exponent, mean power, with respect to s. S is constant, so the derivative will be minus t. So, sorry, the derivative with respect to s means minus and t are constant. So, the derivative is minus t, because derivative of s with respect to s will be 1, and you will be left with minus t. Okay, into, or you can also write it as derivative of this into derivative of the exponent, right? This is the exact rule of differentiation. Differentiation of the exponential is exponential into derivative of the exponent, mean power of the exponential function. So this is t0 to infinity dt e to the power minus st. Now this derivative with respect to s will be minus t into ft, right? And on the left hand side you have d by ds of the Laplace transform of ft. Now you have differentiated it one time. Okay, this question is dn by dsn, right? N is the order of derivative. You have taken first derivative of this thing. You can write it as equation number 1. Now you need to take another derivative of this thing. So take another derivative. Take another derivative with respect to s. This will become d2 by ds, mean d by ds, one more d by ds on left of this d by ds, and this d by ds. So taking the derivative means you need to apply d by ds on both sides. Now this will become d2 by ds square, this, and the function is this Laplace transform of ft, and it is equal to, when you take the derivative, the argument is same as before, that d by dt ds will move inside, and there will be a derivative of e to the power minus st only. Everything else is constant and will be kept same, mean no change. Now this derivative will be what? t0 to infinity dt into, this derivative will be exponential is the same, and the derivative of the exponent is minus t, and this minus t is already present. Now, what are you having now? Please move on the left side, this here. So d2 by ds square of Laplace transform of ft, and this is equal to 0 to t, 0 to infinity, integration is t, dt e to the power minus st, and this is minus 1 to the power 2 into t square into ft. Now, you see the pattern. When there was first derivative d by ds, you have minus t, and now you have d2 by ds means second order of the derivative, and you have t square and minus 1 to the power 2. This everything else is the same. So generalizing, so on, and generalizing, to nth order of differentiation, we get what you get, dn by dsn of the Laplace transform of ft, it is equal to t0 to infinity dt e to the power minus st, and this is minus 1 to the power n. It is of order 2, you have minus 1 to the power 2. When order is n, you have minus 1 to the power n. And same goes for t, t to the power n. Order 2 and power 2 for t. When derivative has order n, then there will be power on t as n into ft. Right? Now, minus 1 to the power n can be taken out because it is constant, it does not depend on t, and you are left with 0 to infinity, integration on t, dt e to the power minus st into tn f of t. Look, this is what? This is this piece. This is your Laplace transform operator. It is L, and it is acting on this Tn, because t0 to infinity dt e to the power minus st, this is identical to the Laplace transform operator. So this has been written as L and this. And on the left you have dn by dsn, Laplace transform of ft. Now look, the result is same as required. No, this minus 1 to the power n is not here, it is with the derivative. So you can move it on the left. So this implies Laplace transform of t to the power n ft is equal to 1 over minus 1 power n into dn by dsn of the Laplace transform of ft. Look, this minus 1 to the power n, 1 over minus 1 to the power n is minus 1 to the power n for all positive integers n. Look, if n is 1, then minus 1 to the power 1 is minus. So 1 over minus 1 is minus 1, and minus 1 to the power 1 is minus 1. So minus 1 is equal to minus 1. When n is 2, minus 1 to the power 2 will be plus 1. So 1 over plus 1 will be plus 1. And on the right hand side you have minus 1 to the power n. N is 2. So minus 1 to the power 2 is plus 1. So plus 1 is equal to plus 1. Right? So this is something very interesting, that 1 over minus 1 power n is equal to minus 1 power n. when n is positive integer of any value. So you can move this down, this minus 1 to the power n in the downside to the upside, and you get so now from here you come this way on the right. Therefore Laplace transform, right, this one. Okay, this Laplace transform of t to the power n into ft is equal to, this is minus 1 to the power n according to this relation, and rest of the things are repeated, means same, dsn into Laplace transform of ft. And this is the result which we were asked to prove in the statement of the question. Look, this is the statement of the question. So your question is done, and if it is possible, you should remember it, that whenever you need to take transform of ft and the variable t is multiplied with some positive power, n is positive integer, where n is positive integer, it is visible from the order of the derivative, because order of the derivative is always a positive integer. Then you need to take minus 1 to the power n, and you need to take nth derivative of the Laplace transform of the function ft, right? This is important. For example, you can solve a question of this type. For example, Laplace transform of t to the power 4 e to the power 3t, and this will be what? Minus, you will need to take minus 1 to the power 4 into d4 by ds square into Laplace transform of ft. ft is your e to the power 3t. So Laplace transform of e to the power 3t. Now you know the Laplace transform of e to the power exponential, mean exponential, as Laplace transform of e to the power kt. This I told you in lecture number 3, that this is 1 over s minus k, where s is greater than k. Now you have k as 3 here. Therefore, Laplace transform of t to the power 4 e to the power 3t is equal to minus 1 to the power 4 into fourth derivative of 1 over s minus 3. K is 3. Now you need fourth derivative of this, and you can take it. Laplace transform of t to the power 4 e to the power 3t is equal to minus 1 to the power 4 is plus 1. Now take one derivative, so dq. So first derivative will be minus 1 over s minus 3 square. Now take another derivative, plus 1 need not be written, d2 by ds square, and one more derivative will be minus 1 into minus 2 over s minus 3 cube. Now you need one more derivative, and one more derivative will be so Laplace transform of t to the power 4 e to the power 3t is equal to, one more derivative mean d by ds will be left, and one more derivative would mean minus 1 minus 2 minus 3 over s minus 3 to the power 4, one increased, and the last derivative is minus 1 minus 2 minus 3 minus 4 divided by s minus 3 to the power 5. And next you have the final answer. Laplace transform of t to the power 4 e to the power 3t is equal to 1, 2, 3, 4 will make plus 1, and it is 4 factorial over s minus 3 to the power 5. So this is how you can find these type of questions. The question ends. This was an extra example, and try to remember this result T and Ft is equal to this thing. I hope you should be able to tackle the questions on Laplace transform now. And thanks for watching. Keep watching. Please like, share and subscribe this channel so that more interesting questions comes to you in the first place. Thanks for watching.